Hello? Is the sound okay? Thank you. One of the last talks of the day. I'm happy that some of you made it. Thank you for joining. Namaste. I've come here all the way from India. That was like kind of a 30-hour flight. With all the thing that was happening in the Middle East, I was not sure I'll make it, but I'm very happy and very glad to be here. This is my third trip to the USA. This picture that you see on the screen is from my first trip. It was to San Diego. It was from a conference I spoke at RubyConf. One of the best compliments I got there, it was I look like the Sundar Pichai. I don't know if you agree, but that was the best compliment ever I have got. But I'm not that. I am Puneet. My grey hair, salt and pepper look kind of make me feel old, but I'm not. I'm relatively very young. I've been in the industry for about 13 years now. I started my career at a startup. 6 years I spent there. It was a crazy roller coaster ride. We kind of built 4 products, 0 to 1 journeys, a lot of learnings there. But then it was about survival. Every year we were like, no money in the bank, let's do something. So I left that job. I moved to enterprise software, the other side of the spectrum, where the company made millions and billions every year, so it was not about survival. That was Coupa Software. I joined in as an IC, and then I transitioned as a manager. Last year, I joined GoDaddy. As of now, I support a couple of engineering teams in the performance marketing org at GoDaddy. Before I start the topic, I'd like to talk about why I chose that topic. I think in 2010, while I was in my college, those days there was no AI, and we had to literally write code in C. Every time I wrote code in C, I struggled, how to allocate memory, how to reference pointers, how to free them up and all of that. My code kind of gave me segmentation faults, and I was like, hey, what do I do? I think some people here I see laughing, so they kind of relate to what I'm saying. Now, a simple program in C, just to take an input, take some numbers, sum it up. You needed to allocate memory, and then you needed to free up the memory of the array. But in languages like Python, if you see, the language does some magic behind the scene. We don't have to bother about all of that, and that actually is magic. This somebody who's written some piece of code inside the Python somewhere which kind of takes care of all of that. Today, we'll talk about that magic. Before we talk about magic, let's talk about my wife and some furniture. I've been married for almost 10 years now. I could not get her here. I'm missing her. But this picture is of a piece of furniture. It's kind of very luxury wardrobe. The best part is this is organized, right? It has compartments. There is a section for the big stuff. There's a section for the small stuff and all of that. It's easy to figure out what's where. At my home, my wife, she exactly knows what stuff is kept where, what is the age of that stuff, if we use that or not. And there are some times in the year when she'll kind of clear them up, resort and all of that. Particularly during the time of Diwali, right? Diwali Indians, we kind of celebrate. It's one of the biggest festivals for us. We do annual cleaning. So last Diwali she came up to me and then she said, can you do some cleaning of this wardrobe? I was like, I can try, but if I do, I'll mess up. She was like, why? I said, I don't even know who uses what is kept there. I don't even know when we bought it and all of that. And if I do, I'll mess it up. I'll make mistakes, which probably my wife will regret. She agreed. And then she did up all of that herself. The point I'm trying to make here is, in a programming language, objects are things, and memory is like furniture. Somebody should know what objects are stored where, how long they are created, are people using it, yes or no. If no, then somebody has to come and clear them out. That is my topic for today. we'll cover of how Python does all of that. A bit disclaimer, like I've been a Ruby engineer kind of all my life. Python, I'm very, very new. I was reading about all of this 6 months ago, and I learned things up, and then that is why I decided to kind of give this talk. But this talk will be like beginner to intermediate, will not go too deep into these topics. This is the agenda slide. AI put this up. The content is good, but as you see, there are mistakes. 1, 2, 3, 4, 5, and 5 again, and 6 again. But regardless, we'll talk about how Python allocates memory. We'll talk about reference counting. We'll talk about the GC, generational GC. We'll talk about some optimizations, and then we'll sum it up towards the end. Again, before we go to Python, let's talk about C. C is a strongly typed language. When you do this something like a int var 10, C knows that you are trying to set this. You're trying to set up an int. It knows what is the memory required for an int. It will set up a pointer, and it will allocate 10 to that. When you change the value of that to 42, the same memory, the same allocation gets changed to 42. When you come and you allocate that variable to a different variable, that is the time where C believes that, no, I should set up a new space in the memory. It allocates a new space, and it creates a new address for that, and then it changes that to 42. Python is different. Python is not a strongly typed language. Everything you kind of put in Python is kind of a Py object. It has something like a type, ref count, and value. Type 543 is an integer, so you have an integer there. Value 543. Reference count 0. This is something which we'll talk about more and more towards this talk. The moment you allocate x to 543, Python understands that somebody is now referencing that 543. So the count of ref count is +1. It was 0 before, and now it is 1. The moment you say x is equal to 654, Python, not like C, it does not change the same object. It kind of allocates a new instance of the Py object, or a new instance of the Py object. Same, ref count was 0 earlier, but now because x is pointing to 654, ref count 1 for 654. If you observe above, like here, this became 0 because 543 is now not being referenced by anybody. So it was 1 minus 1, which is 0. Python is not strongly typed, so you can easily put a string into x. The moment I do that, again, it will not touch the object. It will create a new object. It will create a new instance of Py object, and it puts string, again ref1, and again for 654, if you see, the value goes to 0 because nobody is referencing 654. The moment you do y equal to x, unlike C, the example that I showed earlier, in this case, both x and y will point to the same object. Both x and y will point to the same object. And now, for the first time, we see something like 2 here because x and y are pointing to the same object. When we delete x, it keeps the object, but it reduces the reference. Now the reference to is 1. We spoke about simple objects, integers and strings earlier, but now let's talk about a complex object. Let's talk about a list. A list is something like PyWare object, type list. The value here is not value that you store in the list. The value here is the address which points to the list, which has pointers to the actual values that are stored in the list. In this case, integers. So all these addresses are pointing to boxes, which are Py objects again, all integers, all ref count 1 because you have this list referencing those. One more thing called size here, because this list has 3, the size here is 3. Ref count is 1 because X is now pointing to this list. We spoke about ref counting a lot. We saw cases where it started at 0, it went to 1, it came back to 0, it went to 2 in some cases. But what happens when the ref count goes to 0? There's nobody who is using that object. Nobody needs that object. It can either stay there forever and cause memory leaks and whatever. But Python is smart. It does not let that happen. So there's something called reference counting, which I was talking about. Reference counting is something which kicks into place the moment it sees the reference count of an object is dropping to 0. It will come and it will clear that object from memory. It will clear that object from memory. Same example that we saw. This count was 0 because 543 was not referenced, and now there's something which comes in and cleans it up. The deallocation chain. Some objects could be complicated. Could be a list, having a list, of having a list, and then all of that. So when the reference count goes to 0, ideally we need to clear the entire chain. So what happens is, depending on the structure of the object which is being cleared, there could be different functions called. Like for a list, you will call something like list deallocate. And in some cases, it will trigger cascading effects, because a list, if it is pointing to a list, if you deallocate the list, it will trigger deallocation for all the subsequent list. So it can trigger cascading effects. After the values are cleared, you kind of free up the memory and you return it back to the allocator. Reference counting optimizations. Every language has some optimizations. CPython, one of the popular implementations of Python, also has some optimizations. I'll not go into a lot of detail, but there are 2 things which kind of happen. A lot of things happen, but we'll talk about 2 things here. Small integers, like -5 to 256, some integers are kind of cached. There's a concept called interning, like string interning. If you see like small strings, like hello, these are small string. S1 is hello, S2 is hello. S1 is S2. It is true because Python is kind of reusing the same. It's a small string. Python optimizes to reuse the same object. But to talk about large strings, like this is large string. S1, S2 is not a separate object because optimizations are only in some cases, not in all cases. Circular references. So far we spoke about cases where it was not a dependency, it was like A to B to C. It was not like A to B and then back to A. But when you have circular dependencies like A points to B, B points to A, even if there is nobody referencing A and B, the reference counts of A and B will still be 1 because it's a cycle. They are dependent on each other. Those kind of cases will never be picked up by the reference counting because it is not able to figure out that these references are because of cycle. So reference counting cannot clear that. But if Python is not able to kind of pick these cases and clear them up, there could be case called memory leaks and all of that. For that, there's a different part in the Python language which is called as, or maybe this example again, the same thing I said, A points to B, B points to A, is kind of a circle. Something called as garbage collector. Now this garbage collector, this section is particularly meant for detecting cycles. Whenever it sees a cycle, it tries to understand if there's somebody referencing that cycle. If yes, it will be kept and persisted. If not, it will be cleared. That's the GC module that comes into picture here. There is also optimization that Python chose to do on the GC module. They kind of did something called as generational GC. Now, Generational GC is something like when an object is created, it will be in the gen 0, but when the GC happens, it survives some kind of GC cycles. It is a sign that this object is probably required. So GC will not try to iterate over the same object multiple times, and that is the reason because of which GC will promote it kind of from gen 0 to gen 1. So the psyche is, the intention here is most objects will die young, but those objects which are not dying young, they probably are required. So if they are required, then probably why do we waste resources to kind of compute them every single time? So they'll start at gen 0. If they survive like a few cycles, they will go to gen 1, and then if they survive more cycles, they'll go to gen 0. So that's gen 0, gen 1, gen 2. That's the generational optimization that happened in GC. There are some methods of the GC module. We'll probably not go into a lot of details there, but GC enable, disable. So by default, GC is enabled. Normally we should never be requiring to, kind of calling these methods, but especially in case of long programs, long processes, when we feel that there is explicit need to clear memory, only in those cases we should be kind of manually calling them. Otherwise the language kind of does a great job at automatically deciding when to trigger GC and when to not. There are some more methods here. Threshold, as I was saying, gen 0, gen 1, gen 2 GC, they kind of trigger at different times, and when they trigger is kind of configured by thresholds. So for each gen 0, gen 1, gen 2, you have thresholds. Threshold for gen 0 is like the number of allocations that you have. Once the number of allocations kind of go beyond certain thing, it will trigger gen 0. The gen 1 threshold is the number of times the gen 0 happens. After that, you need to trigger gen 1, so that is the gen 1 threshold. The number of, if the gen 1 threshold is 10, after 10 gen 1 0 cycles, you will have a gen 1 triggered. So those are the thresholds. Get stats, it kind of gives you some statistics on when it was called and all of that. Memory profiling. It's kind of very interesting. When we talk about enterprise software, where I come from, we really need to be mindful of the kind of changes that have been going to production. They are not causing any degradations. We need to be meeting SLAs and all of that. So I had seen people do like observability and measuring of the time, like profile time the program takes, but I'd seen less people focus on memory profiling. So the first slide talks about why is memory profiling important. I believe it's very important because as they say, right, what you don't measure you can't optimize. So you really memory profiling can tell you what is the memory that your program starts with, how much it grows while your program is running, and how much of that is freed up after your program runs. So if your program is not freeing up memory, then the memory at which the program started and the memory at which the program end, the memory end will be more. And that is kind of a sign where your program is holding memory and there are some kind of leaks there. And if we know about all of that, we can possibly solve the issue, and probably we can save some GC cycles that happen in the program execution, and that can kind of speed things up. Because every time GC happens, it will take some resources and the program may become a bit slower. And also some cost, because if we really know that this is the memory ceiling that our program will ever take, probably we can optimize the instances for that level of memory. We don't need a higher instance, and we can maybe save memory time. We can save some cost on the infra, and worst case, if there is a memory leak which is so bad, the program may crash. So memory profiling kind of things can really help figure those things out early, and hence I truly believe that memory profiling is important, and we should all do that. Now, how do we do memory profiling? There are a lot of tools available. I'll not take names. The slide had names, but kind of 3 different tools which I have used in the past. One is the kind of tool which gives you the memory consumed, the RSS, as they say, the graph of that over time. The other kind of tools are like snapshot based. You can run that tool now. It will give you the snapshot of the memory now, and you can run it after the program executes and take a snapshot. It will give the snapshot then, and then there are diffs you can do. So you can do a diff between the snapshot A minus snapshot B, and that tells you the exact memory that the program took. And then you can figure out lines. Hey, this line is taking that, this line is taking that, and all of that. Those tools help there. There's one more tool which kind of summarizes of the memory allocated versus memory retained or the memory freed, and those numbers, if the memory allocated and the memory towards the end, they are not matching, which means that there are leaks. So these kind of tools can really help you find those leaks. I come from enterprise software. My last role, I was working on a very big Ruby on Rails monolith application. I was on the platform team. We had a performance team who used to, keep running some test every sprint and whatever, and kind of report back if the time increased, if the memory increased, and all those issues came to me because I was kind of managing that platform team. Every time they told me that, hey, this is an issue, I was like, where do I start? Because it was a monolith application, hundreds of developers working on that same repo, thousands of commits go in that sprint or two, and then finding this cause is really crazy. It was actually like crazy. And that is a learning, or that is the example which I kind of learned more about profiling, and kind of that helped finding these issues. Some examples that, and these examples, unfortunately, I've not used Python in the production enterprise scale, so I don't have like Python stories to call out. These examples are from my Ruby journey, but the concepts are almost the same. So I think those learnings can kind of even help here. The 3 things that kind of stood out in my career, a process was stuck, and stuck, it was doing nothing, it was not moving. We used some profilers. Those profilers literally helped us to point the line of code. That line of code was basically doing a regex match, and that line of code was called 1,000,000 times. And it was a very expensive regex match you were doing. So we kind of optimized the regex, and that kind of helped us. But profiling literally helped us to get to the line and fix the issue. The second is multi-fold increase in the app boot up time. Oh man, that was a crazy thing. The app boot up time basically is directly proportional to the time in which you can start a new machine. This again, profiling helped us. Towards the end of this slide, we have 5 more minutes, so I'll kind of talk about 2 more things. While I was submitting the CFP, I was like, are people in the modern day world even interested to know about this? Memory management, like why do people care about it? Even today, I was passing by, there was somebody talking, they probably didn't know I'm talking on this, but to talk to each other that, why do we have a talk on this topic now in the day where we don't even write code? I was like, great, but I'm probably the old guy in that picture. Oh, sorry. Still telling people, and I tell it to my team that fine, use AI, which is fine, end of the hour, we all need to use AI to kind of optimize for time, but we just cannot afford to miss all the basics and have no idea of things that are happening. Yeah, the code may work still, yes, great, the code works, but we really need to understand the depth. Otherwise, we are not setting up, We are not setting us for success. Few years down the line, maybe. Yeah, we really do bad things. And it's kind of what I tell to my team. In the age of vibe coding, great engineers would still win on fundamentals. The fundamentals that we all have, they should be with us, and we should still work to learn more and more and more. The last thing is, in the world of AI, people talk to AI for everything. Help, ask AI. Write code, ask AI. Code review, ask AI. It's good because it's kind of helping you move fast, yes, but the relation, we are humans, right? Humans grow as humans by talking to humans. That's what I personally believe. And if with all of this we kind of use the human touch, we may grow as programmers, absolutely yes, but we may not grow as humans. So I think we should still always have that human touch in the interactions and not let that go. Credits, I use a bunch of references. Thank you. That's kind of my time. You've been a very patient, a very quiet audience. Thank you. Hopefully you enjoyed. Thank you. That's my time.